Good evening. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and tonight's topic is what are the types of engineering surveys? What are the types of engineering surveys? But first, we must understand before we get into the types, what is surveying or land surveying, and what is the purpose of surveying? Okay, the main purpose of surveying is to determine any relative position of any objects or points on Earth. So basically, what you're doing is you're determining distances and angles between various objects. And you're also preparing a map or a plan or a plat to represent an area on a horizontal plane. Now, what is surveying? I just gave you the objective of surveying. Well, basically, surveying is the technique, profession, art, and science of determining the terrestrial, two-dimensional, or three-dimensional positions of points and distances and angles between them. Now, a land surveying professional is called a land surveyor. If you have a license, you're a licensed land surveyor or professional land surveyor. But when we get into surveying, we start talking about the types of surveying. Well, and this is surveying 101 here, we have different types of surveys. And they're very important. You have to be detailed and you have to understand math when you do surveying. The first one is known as a ALTA ACSM survey. Now, basically what that is, it's surveying standard jointly proposed by the American Land Title Association and the American Congress on surveying and mapping that incorporates elements of the boundary survey, mortgage survey, and the topographical survey. ALTA or ACSM surveys frequently shortened to ALTA surveys and are often required for real estate transactions. Next survey you have is, it's known as an as-built survey. That is a survey conducted after a construction project is completed, which it confirms that the structures, utilities, and roadways proposed were built in the proper locations authorized in the plot plan or site plan. Then we have the boundary survey, and that's basically a survey to establish the boundaries of a parcel using its legal description, which typically involves the setting or restoration of monuments or markers at the corners or along the lines of the parcel, often in the form of iron rods, pipes, or concrete monuments in the ground, or of course, they're nails set in concrete or asphalt. After that, a drawing is then prepared from the field data to provide a representation of the parcel survey. Then we have an elevation certificate, and that is done by a survey drone. And a survey drone is used when a parcel of land is located within a flood hazard area, as shown on the FEMA maps. And on those FEMA maps, you then look at the elevations. Why? Because the elevations are determined for the finished floor, garage, accessory structures, and adjacent building grades. Now, this information is then put on a flood elevation certificate to determine the insurance coverage needed as determined by the insurance agent. Then we get into engineering surveys. Engineering surveys are basically associated with the engineering design. You have layout, as-built, and topo. Topo is known as a topographical survey. And with those surveys, they require geodetic computations beyond normal civil engineering practices. Then get into building or construction survey, we start talking about a foundation survey. And basically what happens with a foundation survey, the use of a drone again comes into play, and that drone is used to collect the positional data on a foundation plan that has been poured and is cured. Now, when we talk about a foundation, we're talking about a slab, like if they're putting in a building slab or a basement, they poured concrete. Again, you don't hear too much about a foundational survey because that kind of incorporates itself with construction. Basically, for a foundation survey, you use a drone to collect the positional data on a foundation. That's foundation, not a foundation plan. A foundation that has been poured and is cured. This is done to ensure that the foundation was constructed in a location authorized in the plot plan, site plan, or subdivision plan. When the location of the finished foundation is checked and approved, the building of the remainder of the structure can commence. This should not be confused with an as-built survey, which is not to be done until all the work is completed. Then we get to a hydrographic survey. That's a survey conducted with the purpose of mapping the coastline and seabed for navigation, engineering, or resource management purposes. Products of such surveys are nautical charts. And we get into the mortgage survey. It's a simple survey that generally determines land boundaries and building locations. Mortgage surveys are required by title companies and lending institutions when they provide financing to show that there are no structures encroaching on the property and that the position of structures is generally within zoning and building code requirements. Next, we get into plot plan or site plan. That's basically a proposal plan for a construction site that includes all existing and proposed conditions on a given site. Now, the existing and proposed conditions always include structures, utilities, roadways, topography, and wetlands delineation. The plan might also, but does not always include hydrology, drainage flows, and flow zones determined from FEMA, which is you're basically dealing with a federal flood insurance reference map. Then if you are taking surveying classes to get your survey license, you have to understand subdivision surveying. Now, when you deal with a subdivision survey or a plat, it's basically a plot or map based on a survey of a parcel of land. Why? Because boundary lines are drawn inside the larger parcel to indicate the creation of new lot, parcel lines, retention ponds, and roads. Again, when we deal with a subdivision, you're basically laying out an area where they're going to be constructing lots. And when they're constructing lots, you're going to have your water and sewer, you're going to have your streets, you're going to have everything that's going to be dealing with that subdivision to make it operable. So again, a subdivision plat is a plot or map based on a survey of a parcel of land where you have boundary lines that are drawn inside the larger parcel to indicate the creation of new lot or parcel lines, retention bonds, and roads. Then we get into everyone's favorite. If you are surveying, and this is when you have to locate everything. That includes trees, edge of pavement, fences. This is where you get your coordinates from. and we're talking about a topo or topographic survey. Now, a topographic survey is a survey that measures the elevation of points on a particular piece of land and presents them as contours on a plot. Again, when we deal with a topo, you also have to go out and basically shoot different points, and you can create a map with a topographical survey. You may shoot points along the road. You may shoot points along the building. You're going to shoot trees. You're going to shoot overhead power lines. Anything within that boundary where there is a proposal of a construction site, you're going to create a map with all of the points that you shot in the field. And then once you shoot all those points, you're going to put them into a data collector, and you're going to download everything from a data collector onto a software like Civil 3D, Carlson, BriskCAD, and each of those points that you shoot out in the field, they're given a number, and they're also given a code. Let's say you're shooting the edge of pavement, where you're going to be coding that point as EP. What if you're shooting a building corner? You might say building core. But all those points that you shot, they're going to come with a code sheet based on the software that you're using, because those points that you shoot out in the field, when you form that map, you're going to create a plat. You can create a boundary survey from a topographical survey. It's very important. You can use that topographical survey for construction, but it's very important that you go out and shoot all the points on that property before construction can start. Now, you have other types of surveying as well, like route surveying and construction surveying, where you're going to get cuts and fills when you're placing a road or you're putting a dam in, or any type of structure. And you have cadastral surveys, photogrammetry, and you have survey computations. You basically use a lot of survey computations when you are basically correcting error when it comes to closing a traverse. And the last one I want to present to you is the Wetlands Delineation and Location Survey. Now, that is a survey that is completed when an authorized biologist or scientist has marked the wetlands. Now, what are wetlands? Wetlands could be any area that it looks like a pond and it has high grass growing around it. And those wetlands, that they're for the environment. In fact, when you are getting ready to build something, you'll see geofence go up to keep sediment from going into the wetlands. Wetlands are very, very, very important, because right now, everybody is into the environment to make sure that the environment is clean. And in the past, nobody cared about the environment, and there was a lot of pollution, a lot of water getting dirty. We have to drink that water. So your wetlands, your wildlife, they're all protected. Now, of course, the boundary of the wetlands is determined by observing the soil colors, vegetation, erosion patterns or scour marks, hydrology, and morphology. Typically, colored flags are then placed in key locations to denote the boundary of the wetlands. So basically, a survey is done to collect the data on the location of the placed flags, and a plan is drawn to reference the boundary of the wetlands against the boundary of the surrounding plats or parcels on land, and the construction work is proposed within. And there you have it, surveying, very important. Surveying is tied to civil engineering. You can get a surveying license by taking some of those courses. Something else that's part of surveying that I didn't mention: mapping, cartography, coordinates. So we deal with GIS. Let me go in here and try to show you what some coordinates are like. Just bear with me. Let me go in here and get the coordinates for you. Share my screen. Okay, I was talking about coordinates before when you go out and shoot points. All right, these are what you call coordinates. And you see all of these codes: PT, that stands for point of tangency, point of curvature. You see, when they shot this point, there's an iron pipe, there's a gate post, there's a building, there's a concrete structure. This is what goes into that data collector, and all these points are then dumped into a CAD file like Civil 3D. And these are very important. This is what all the coordinates look like. And each coordinate point is given a number. And what I have here, you have roughly 199 points. Now, is there a code sheet? I believe there is a code sheet. Let me see if I can find that code sheet. The coordinates, code definitions. Also, there are what we call code definitions. When you go out and shoot the points, these are all your code definitions. Remember I told you about edge of pavement, EP, edge of crushed stone. These are all the points that are put into the data collector and coded when you go out there and shoot points when you're doing a topo. And you use this sheet. Remember I told you about point of curvature, PC, point of tangency. Well, all this information is what you use to create your plat. So when you go out surveying, got to be very detailed. Got to understand what type of survey that you're doing. Surveying is very, very important, and you want to make sure that you understand what's going on out there, because there's laws with surveying. In fact, when you put points down, somebody tries to intentionally take away a surveying point, there could be some liability for that, because basically all these points, you're retracing a survey that was placed by original surveyors. And in the United States, you're dealing with two systems. When you deal with the bearings, you deal with the ASMIS, that's meets and bounds surveying. Now, here in Indiana, Ohio, we deal with townships and ranges. That's known as the public land surveying system. Now that you've got an overview of the types of surveys, that concludes this topic on types of surveys. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political and social content, check out my main channel, the 411 Talk Zone Radio Show channel, also on YouTube. You can't find the 411 Talk Zone Radio Show, QCIS channel on YouTube. You can find my videos from both channels on my Twitter page. Now, because the QCIS channel is an educational channel, I take it one step further. You can find the QCIS channel and all the videos that I produce for the QCIS channel on my LinkedIn page. And once again, thank you for viewing this content on types of surveys from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones. I want you all to have a wonderful, gracious evening.